Hi, welcome to my channel Data Networking. Uh, in this particular lecture, I'm going to talk about how we can hide the MPLS core IP detail when we execute a trace from one customer device to another customer device, which is passing through the core network. Right? Uh, as I explained earlier, that in a normal situation, when any of the P device, right, will do a new label imposition onto a particular IP packet or a particular IP header, it always decrement the TTL value and copy the TTL value to a label stack. Okay, but if we have to hide the detail, okay, the MPLS core IP address, okay, we have to make sure that none of the P device will generate the TTL exceeded message. Okay, if any of the device will generate the TTL exceeded message, then probably the customer will know about the ISP core IP address. Okay, how to avoid that? So how that we can avoid if we put the TTL value as a maximum value inside the when any IP header is coming. So instead of copy the TTL value from IP header to uh, label stack, we can simply just put the maximum value so that no one in the core device will generate the TTL exceeded message. Okay, I will come to that operation later on, but first let me explain what are the commands to uh, uh, are used to hide the core detail and what's the use case, right? So these are the commands here. Excuse me. Okay, uh, there are three options, right? First of all, let me show the traditional trace route. For example, if I try to ping from trace route from my source address 7.7 to destination, all right, so this is my source and this is the destination. So this is my trace route. Okay, and here I can see the MPLS labels down the path, and this is something we want to hide here. Okay, multiple options are there, and the you can see that the commands are here. MPLS TTL propagate disable. What exactly it will do? It will simply hide the ISP code detail from the customer as well as from the provider itself, which is really not a good idea when someone has to do a troubleshoot from the ISP level. All right. Second command is to use the MPLS ip-ttl-propagate disable forward. In this particular with this particular command, we will hide the ISP core IP detail from the customer, but then it is visible for the ISP engineer itself, which is good for the troubleshooting purpose. Okay. Third option is the opposite of this one. Here you will not hide the detail for the customer, but you hide the detail for your own as ISP engineer, but this is not really a recommended option. Okay, now before the demonstration, let me show how the overall operation will look like in this particular case. Example, now let's skip the probe 1. When probe 2 is happening, okay, in the earlier discussion what we have observed that P device, the ingress P device was doing the copy of the TTL value from IP header to the label stack. But with this command, with this particular commands, okay, instead of copy the TTL value, it will set the TTL value to a 255, and based on that, no one in the core will able to generate the TTL exceeded message, and now uh, your the complete, I mean to say, the probe of the trace route will reach to an end device. Okay, this is the way I will explain. For example, when this trace hitting the ingress P, it will set the TTL to 255, decrement it to 254, remove the label stack. It will copy the TTL value back into a to the VPN label, which is a 253. Okay, now here is a thumb rule in MPLS. Okay, what is saying that it will not copy that TTL value from VPN label, okay, if it is greater than the IP TTL. Why? For some reason, if it will copy the TTL value it will copy the TTL value from label to IP packet. What if this IP packet reach to this P device and this P device will again set the again the maximum TTL value, and it will always, it will be a like it will continue in this IP will be remain in the network forever, right? So just to avoid that scenario, there is a thumb rule, okay, that when this the label will be removed, for example on this particular, when the label stack will be clear on the egress P, it won't copy the VPN label TTL value to IP header. So your the initial IP header is intact, okay. When the it will reach to the end device, it will remain as it is, like a TTL value 1, okay. And when it will reach to this particular device, since is a way of the Cisco working, that when it will see a random port, it will just generate a port unreachable message, and the message will then follow the reverse path, okay. And the you can see that in the reverse way also it will decrement the TTL value from 255 to 254 here, okay, because uh, I'm explaining that operation from this device perspective here, and down the line the trace route will be completed, right? So let's see in the demonstration how the behavior is changed when we apply this command onto the device itself. So quickly, uh, this is my R7 device, and I'm using the Cisco SXR. It's a virtual environment, okay. So let me log in here. This trace, we know that we can see the MPLS IP. If I do a trace from this P device to this P device, well, let's see what kind of IPs we can see. Okay, I can see the MPLS core router 4 and the router 6 down the line, okay. Now let's apply the command here. Yes, let's apply this one here, okay. So what it will do, it will applicable on the P device, okay. It will hide the detail, okay. It will hide the detail of the MPLS core by setting the TTL value to 55, and it is applicable for both service provider as well as the customer device, okay. And let's commit it. It's done. Now do a trace from the CP. Now we can see we no longer able to see these packets, because now it's sending the it's setting the TTL value to 255, okay. And if I look into the provider perspective, let's see, it should be the same. Oops, it's the same. So we are not able to see the MPLS label here, okay. Now the second option is not it's not the desirable case, as a ISP engineer has to, if he has to troubleshoot, how it will be troubleshooted, right? So now with the second option, along with the disable, but we add a keyword forward, okay, and commit. With this option, when P device will generate its own trace packet, then the TTL value will copy from the original uh, header to a MPLS IP header to the MPLS label stack, okay. But from the but for the transit packet, okay, like the transit packet, the traffic for from the customer to customer, the operation will be the same, like the option one we have seen here, okay. So if I do the trace again, as I mentioned, nothing changed from the customer side, but if we do a trace again, okay, now we can see that we can able to see the core IPs in the trace itself, okay. Third option is quite is opposite to the second option. So what it will do here, now for the self-originated P packets, okay, the TTL value will be a maximum value 255, but for the customer traffic it will be uh, uh, like it will uh, the native operation, okay, it will copy the TTL value from IP header to MPLS the, the MPLS label stack, okay. So for example, if I do the trace here, as expected, I won't see anything here. I just able to see this particular IP only, which I does, right? Uh, it's not really a recommended solution, because as a ISP engineer, someone has to know while doing the trace what are the next the particular IPs down to the path. Okay, but if I'm doing the trace, now I can see this as option. Okay, most of the time the option 2 is available in the service provider environment, because with this option 2 we are hiding the detail, the code detail from the customer, but we are not hiding the detail as your own. Okay, like for example, if I apply it again, so commit to trace, I know what are the IPs, the core IPs in the path, and when doing the trace from the customer, we can see that we're not able to see any of the ISP IPs down the line. Okay, with this I think we can conclude the video. Thank you for watching. Stay tuned for the more videos. Thank you.